All right, let's do another example, and we will use a second derivative test to find the relative max or min of this function right here. To do that, we'll start by taking the first derivative, f prime of x, which is simply going to be equal to 9x squared minus 36, and the negative 2 goes away. Let's go ahead and find the second derivative, f prime prime of x. That is going to equal 18x, and the negative 36 just goes away. So we got our first and second derivatives just like that. That's always a good way to start the problem. Now let's find where our max and mins are, and we do that by setting the first derivative equal to 0. So 0 equals 9x squared minus 36. We want to solve this for x, so we add 36 to both sides. And we get 36 equals 9x squared because the 36's cancel. Divide by 9, divide by 9. We get x squared equals 36 over 9. And that's nice because when we take the square root of both sides, we'll get x is equal to positive or negative 6 over 3, which of course is equal to positive or negative 2. So there we go. We got positive 2 and negative 2. By the way, if you happen to plug those two values into the original function, which I've already done, you get 250 and negative 246. So I went ahead and did that. So let's find out if these are maximums or minimums. If we were doing the first derivative test, we'd have to test points and see if they go from down to up or if they go from up to down. But with the second derivative test, it's a lot easier. Just plug in your x value of 2. We see that that's a positive in the second derivative, so that means it's the reverse. This is a minimum. And we're done. Isn't that great? If I plug in negative 2 into the second derivative, I get 18 times negative 2, which is negative 36. That's negative, which means that this is a max. If you're not sure about why that is, go ahead and re-watch the earlier video, but basically it's because for negative 2, we get a negative second derivative, which means we're accelerating up, which means it produces a minimum. I'm sorry, I got that backwards. See, it's confusing. When I plug in negative 2 right here, we get negative, which means we're decreasing downward rather, which creates a maximum. When I plug in the positive, I get a positive, which means that we're increasing upwards, which produces a minimum. Sorry, it's really easy to get it backwards. We'll try to do better in the next example.